Hello. Yeah, we will begin in 2 minutes. Okay, so I think there should be some more students. Good afternoon. Okay, let's begin. So just a recap of what we talked about last time. Okay, so let me open the slides. Yeah, we were talking about the history of internet, right? So by that time, we discussed that internet actually evolved originally from ARPANET, which is supported by Department of Defense, right? So so originally there were geographically isolated subnets, okay? And then as it evolves, finally, there are like internet service providers, routers connecting those subnets, okay? And this forms the internet backbone these days, okay? And this actually the infrastructure that we are all connected with in the world, right? So if you do not have access point into the internet, you can still form a subnet yourself, right? So this is called an ad hoc network. We'll see later, okay? You can have some like device, just like Bluetooth to transform, like transfer files, or you can form a local area network where you can play computer games together, right? So, what defines you to be connected to the internet is really you have access point with the internet service provider. Then you basically you get into the backbone infrastructure of the internet. Okay, and again, different subnets are connected by routers, right? So that because there are so many end users, so how to route the packets between different machines is through these backbone services. And this is a development over the years, and these days there, it's so prevalent. Everyone has multiple devices connected to the internet. And last time we talked about these milestones in history of internet, right? But you don't really need to memorize them. Okay, so this is we were not likely to test any question, especially asking you which year what happened, right? So, but you need to be aware like certain things, even though we do not require you to memorize. You need to know that Winston Cerf and Robert Kahn are like the inventor of TCP, right? Or the implementer of TCP, right? So, and they won the Turing Award, right? And there are also a TCP IP flag day, where originally they was using another protocol, which is NCP for transport, right? And then there's a TCP flag day back in 1983, where everyone flipped to the new protocol, right? So these days, people are moving from IPv4 to IPv6, right? So, and these kind of milestones that you can understand a little bit, right? And so what's next, right? So here are a few important applications that is developed all the time, right? So we will talk about the layered model, right? The OSI layered model, like 7-layer models, okay? And last time we have seen that model, I think, in some slide, but we will discuss it in more detail in the next slide about architecture, right? So on top of the layer is the application layer, where they can use, for example, socket programming, okay? That we will have the project on maybe in a couple of weeks, right? Programming projects, by the way, okay? and where you can send like TCP, send the stuff to the other party, the other machine using TCP. Okay, so that's a transport layer. Above transport layer, you have the application layer. Right? So we'll talk about it in the next slide. Okay, so this is the top layer, right? So where we have the applications, right? And we are not talking about those apps in like a Apple Store these days, right? So you can have like each service, each company may want you to use their own app, right? So every company will develop an app of their own, right? We are talking about more like still more infrastructure level apps, okay, that back early on, right? Because, back at the time, you are just having information that can send from one machine to another, right? How do you define a set of meaningful applications that will be used by people, right? And people all find these things are very fundamental and useful, right? So that takes time to form, okay? Just like, in Microsoft Office, right? You have Excel, you have Word, you have PPT, right? So these things don't come, in one day, right? So this is carefully designed, right? So now there's a team, right, in Microsoft. They have evolving products and apps. Okay, so here's this page lists a bunch of more like earlier apps, okay, which are more fundamental, right? So for example, email is probably one of the earliest apps, right? So once you have internet, the first thing you want to replace is really mail, right? So because mail is so slow, okay, and you can send things to email, right? So and the other party can immediately get it, right? So and again, they can receive the email less frequently. Let it sit in the mailbox. Okay, so we will see how this is implemented in a later lecture. So I see a question. So we will use a socket programming. You can either use C API or Python API. We will not suddenly let you just do a project. We will tell you the APIs and what you can call the libraries. Okay, so don't worry too much, right? And yeah, so there are different technologies, right? Socket programming and remote procedure call. There's even zero message queue and there's higher level stuff, right? So we'll really look at the most basic one, right? Socket programming. Okay, that's really early. Okay, so there's a C socket. C is kind of very old technology these days, right? But so you can use Python. It's the same API basically, just in different language. Okay, and you will get familiar with the socket program. Okay, so I hope I answered that question. And then after you have the email, right? So what you want to do is really, you want to control the machine, right? Remote, like these days we have the team viewer, right? So the remote desktop access, etc. right? So for that, usually, if you want to connect to the other machine and do some operation, right? You first need to connect to that machine, okay? And these days we all use SSH, especially if you are using, using Linux or Mac machines, right? So secure shell. Okay, so but for old days, SSH itself is a breakthrough, right? It provides security. It's secure shell. Okay, secure shell, S shell, right? Okay, and in the old days, we also have another app called Telnet, right? So I think if you were using Windows a long time ago, right? So Telnet is by default the program that is in Windows. Okay, so you can call it out using the console. Right? Okay, so you can use Telnet to connect to another machine to do some control or do some access of the results. Okay, but it's not very convenient, right? So for example, if you want to really just to do a particular operation, let's say I want to upload a file to the other machine, let's say a server, and I want to download that file, right? So there's the FTP, okay, FTP file transfer protocol, right? So this is remote files. Once you have the FTP, then you can just displaying the folder like this in the other machine and your machine, right? So you can see what's under there, and you can say, hey, I want to download this file, or I want to upload my file to this location in that machine. Okay, so this is specific to file transfer. Okay, between machines, right? And of course, before that, we have the DNS, right? DNS is really the phone book of the internet, as we talked about last time. Okay, this is domain name service, right? So which means you don't want to access Google using the IP address, 4 numbers, right? So you want to really just say google.com. Okay, for that you need to have some way to know that google.com goes to that machine with that IP address, right? So for that purpose, there are some global domain servers. Okay, so let me give a graphical example. So for example, this is, let's say, the world map, right? So there's a continent. Yeah, it's just illustrative. It doesn't make much sense. Right? This is Asia. Maybe this is North America. This is South America. Okay, right. So there will be a bunch of top layer domains name servers deployed somewhere. Okay, but what if, let's say, UAB, let's say in Birmingham, we want to access google.com, right? So if we always ask for the domain server for them, right? So those domain servers usually have very top level stuff, okay, like a Southern.com, everything.com is in this domain server, or everything.edu is in that domain server, okay? So then let's say every university access, you visit any university website, will go to that particular server. That will crash the server, right? Actually, there's like a local cache, okay? As long as one user in Birmingham visited that, like uab.edu, then the IP address to the domain server name will be cached locally, okay, in some location, and then you can access it. Okay, it can be even cached in your machine. Okay, that also means if you change that domain, domain to IP mapping, right? So let's say you close a current service, you connect the domain to another location, right? So like your space is expires, you switch to another space provider, right, and connect the domain there. Okay, in that case, it will take half a day for everyone to be able to see the new website. Okay, because they may still access the old server with the old IP address, but that one is no longer serving, right? So it's expires. Yeah, so this is DNS, and let me switch back to the color. Okay, and there's also NFS. NFS, as we discussed last time, right? So if you have, let's say in the department, you may have many servers, okay, but you always log in and see home and your username is the same disk space, right? You're accessing the same disk from different machines, different servers. Okay? That's because that disk is mounted using the NFS probe. Okay, and so. And what Wide Web, right? So this is really, HTML in the old days. So hypertext, right? So, and the browser can visualize this. Right now we have the Web 2.0. You can interact with the server to access something from the database and compose another website and send it back. Right? Okay, and so that's basically. By 1995, which is really, really old days. So now we all take it for granted. Okay, and so, but you can imagine by that time it's really a big deal. Okay, if you think about there's no internet earlier. Okay, but then we have like a messaging like ICQ. Right? So these things right now it doesn't matter that much. Right? So you're using Twitter or using, Facebook, and they all have this kind of messaging, right? So you can easily communicate with people. Okay, and even just in in Gmail or somewhere you have a box, right? Just popping up, you can communicate if you want, right? And by that time, this is a big deal, right? Because this is the first time this idea of instant time messaging comes about. Right? Before that, people are sending emails. You know there was some difference there, right? So from the interactive feelings, right? So, and then Google comes. This is really, now that we have so many websites here, right? But how do people visit website? People visit the website using domain names, right? Okay, google.com. But there are so many websites, right? So you cannot remember all the domain names. Okay, it will be crazy, right? What you really care about is, for example, searching. Okay, one particular example is keyword search, right? Google is using keywords. So you care about this content, right? You compose a keyword, and then you want the search engine tells you what are there on the website. Okay, and the Google's job is just to go to everything that is connected to the internet backbone, right? To probe every machine and crawl all their content there, and then build an index. Right? If that website has a keyword, it has an inverted index, say, hey, this word has this website. And then another important thing is to rank them. Right? And previously, Google using PageRank, right? So if you've heard of PageRank, okay, but it's no longer in use. Okay, it's outdated. They use the semantic web these days, which they claim to be more accurate. Okay, so I'm not familiar with that technology, but PageRank and inverted index are really old information retrieval technologies. Okay, And then there's a concept of peer-to-peer, right? So before peer-to-peer, all we do is called the client-server mode, okay? And CS mode, C is client. There's a one dedicated server or a group of dedicated servers, right? So for example, if you think about Google keyword search, that's definitely more than one machine, okay? It could be the data center of Google with a bunch of machines, right? And so to share the workload, okay? And also, C, the client can be browser. So the nice thing about browser is that, so you don't need a local client to run dedicated program. The server will, according to your request, compose the website and show you what you should show. The browser just show it, okay, according to the HTML or this kind of hypertext setback. Right. So a lot of things are just handled by the server, even on how to show these things. Okay. And on the client side, you may run some like JavaScript, those kind of script to make those things happen. Okay. And there's some, so this is the old style, right? This is still there. Okay, most is dominating. Most of service still client server mode, right? Like if you go to uab.edu or computer science department website, right? It's all like there's a dedicated server there, right? So just to answer you can have different client, right? Like your phone with that website, but the website is always that server with the same and fixed IP address. Okay, this is also our assumption for the socket program project, right? So we will have a server program, and later we will ask you to write a client program to interact with the server. And the server program follows the same protocol like TCP, for example. Okay, and that's the socket program API, right? So the lower layer doesn't matter to you, right? So you just use TCP to communicate. Okay. Right, so in that case, you really, it's modularized. We will see this later, okay? And you don't even care about the language. You can use C, you can use Python, as long as the same TCP protocol, right? And the same content on the while, right? The packet format, so you can communicate, okay? And so the peer-to-peer, right? So it's actually causing a lot of workload. Peer-to-peer as a concept is this: we don't have this server, okay? We have all clients in some sense, right? But we don't call them client, right? So client is really not holding any duty. Okay, peer-to-peer is both a client and a server, okay? And so basically our assumption, for example, in the ideal case is that, this service is all around the world. So not all peers will get offline, okay? But for example, if you have a movie, right? And we assume the movie is distributed to enough people, okay? Right. So then, even if a certain fraction of them get offline, right, there's still maybe 10% people online, and you can get the movie from them. Okay. So there's a lot of way to guarantee this. Okay. And frankly speaking, even so, this may not have service guarantees. There's actually, if you look at the P2P service providers, they actually also have local servers actually. Okay. Just in case there's no peers, they will play the part. Okay, and get you the movie. Okay. But the ideal case is you just rely on the peers. Everyone do some service and do some get some service and provide some service. Okay, and the assumption is that there will always be some peers on the network alive, so you can always get that resources. Okay, and yeah, this caused a lot of traffic compared with the old days like email or those text stuff, right? So because like Napster is really for music, right, and BitTorrent usually for videos, right? So this is really, causing a lot of burden to the internet service provider. And back then they have a lot of complaint about peer-to-peer technology. Okay, and if you look at blockchain these days, it's essentially peer-to-peer. Right? So because everyone has a so if blockchain, right, it's a chain of blocks, right? Everyone need to keep one copy and to verify it. So make sure, like especially those miners, make sure there's no cheating there, right? So it's essentially still peer-to-peer. It's extreme peer-to-peer because everyone have a copy, right? So, of the transaction record of, let's say, Bitcoin. Okay, and if you look at the moving forward, right? So I think Google is really something important, right? Peer-to-peer is more like a technology. There's a lot of companies in this, right? Google keyword search is really dominating, right? Maybe there's Bing, etc., but Google apparently is clear winner. Okay, and so the next one that is clear winner is social network, right? So Mark Zuckerberg. Originally, I think he's in Stanford, right? So he just programmed this this kind of social website, right? So where put everyone into the same database, so you can share stuff and you can communicate with each other, but it's the same backend, right? It's like connecting everything in the same backend. Okay, so if that is the case, basically you can provide a unified service like games or like some communication channel or how to share, right? This actually matters a lot because it's very human in some sense, right? So a lot of people are using it, right? So actually, I think Facebook is probably a clear winner in social networks, right? So uh, uh, other than like Twitter, but Twitter has to shoot for a different market, right? So you should have short messages. Right? Facebook can be. I think now it's kind of still similar, right? So because I think Twitter has doubled their messenger restriction, right? So anyway, but in the old days, right? Because Facebook is there, so Twitter has to shoot for really short, like 140 character messages, right? So shooting for another market where you want really fast reading, okay? So and yeah, so and the model is also different. Like Facebook, you have to be mutual friend, right? And Twitter, you have to be right. You follow somebody. That person don't care about you. It's possible, okay, right? And so there's some difference, right? So otherwise, you don't compete with a winner already, okay? And there's also YouTube, right? So YouTube is video sharing, okay? So every user of YouTube actually is also a you can also post a video, right? To I think it's mostly using Google Drive. I'm not really sure. Okay, I don't know whether there's a size limit for the video. Okay, but when your let's say your subscription reaches like 1,000 or how many hours, then you can start making money, right? Because this is a content provider. Okay, this is the internet content provider. They build the infrastructure but rely on users. Okay, to provide the content, and then they can give you some advertisement, right? And then they can ask for money from those companies. Okay, so this is how it works. Okay, so YouTube is really making things a lot easier, right? So if you look at education, right, there's a lot of good materials online, and the question is where you find them. Okay, it's actually in an age where everything is there, but the important thing is you need to have a kind of like a search engine, right? So the duty of a professor, for example, is more like a guide you to the right results and the right path to study. Okay, because you have the library maybe, but it doesn't mean you have the knowledge already there, in your mind. Okay, so and we are posting our course videos to YouTube. You should be able to access it. Okay, if you cannot access it, just let me know. We will send an email about where we post after each class, after I upload it. Okay, and you can rewatch the video to get the idea, right? And so another technology is the iPhone, right? So the Apple Store. Okay, so apps. These are the apps, right? So previously we called it applications. Right? So when we really call apps, it's really fashioned by the term of since the App Store, that's Apple Store. Okay, and so yeah, they are also making money, right? If you have an app and you are making money, you need to give Apple Store some money. Okay, so and this iPhone, I think Apple is a more kind of engineering style, right? Because if you look at their product, right, it's really aesthetically nice and thin or small, right? So it's a hardware kind of revolutionary in some sense, not just like the software. But again, if you look at the mobile device, right? So this is a network improvement, right? So in the old days, people don't see, right? If you look at Nokia, they lose the market because I heard that the CEO there says, "Hey, we have the computers with so much large screen, right? Why people want to play games or do everything on a small screen form, right? And they don't do the smartphone, right? So that's why they lose the market. Actually, that mobile networks these days are actually, having more markets than in the old days, right? Everyone use a PC, okay? Now, a lot of people don't even touch the PC. They use a tablet and they use their phones. Okay? And if you don't do that, you lose the market, right? So now it's kind of, there's a lot of things happen since then, right? Like, there's a controversial TikTok, right? So, there's something happened really. So there are a lot of apps. Okay, so right. So any questions so far? So these are all the top layer application layer stuff. Okay, and you can do your app. Okay, there's no restriction to app because it's the endpoint. It's the top layer. Because there's nothing on top of it. You can design whatever you want. Okay, yeah. So what's next? So you may imagine, right? So and you can develop your own app and make big money, right? And yeah. So the takeaway message from this history lecture, again, it's just to build a mindset. It's not for the purpose of letting you remember which year what happened, okay? But you are aware of, hey, in early days, that thing happened, right? Or there's something like that. That's good enough, okay? We will not test the history, okay? But this will help you in later lectures to understand everything better, okay? So because you have the right mindset to accept what will be followed, okay? And yeah, so one thing you know that communication is fundamental to human nature, right? So these days it's irreversible process, right? Once we have the internet, right? It's just maybe 30 years, right? So but you cannot go back basically, right? So maybe you travel to another city to some get to the hotel. The first thing maybe you connect to Wi-Fi there, as for example, or you just communicate with friends, right? So if there's no network, right? So especially during the pandemic, it will be a disaster. Okay, it's an irreversible process. Okay, it's unimaginable early on. Okay, right? If you think about if the pandemic happens maybe 50 years ago, right? So there's no way we can do this kind of remote teaching, right? So again, yeah, we should definitely add Zoom to do the application. Okay, right? So the remote conference, okay, teleconference. Okay, and there's a lot. I think there's I think there's 3 or 4, but Zoom is doing, maybe the app is really well done, so it's dominating in some sense. Okay, I think there's a WebEx or something, right? So I remember there's a bunch of those kind of software to do. Okay? And another thing that happens these days is that those apps are like winner take all, right? So because if you are used to Zoom and how this interface looking like, where's the button, right? Why you bother to use another platform, right? So these days it's no longer a technology; it's more like a market, like a business, right? So and how you win the market, right? Market share. But in the old days, all these are not possible without internet. Okay, you have an idea of the app, and then you that's not considered by other people before, and it was huge need, right? So huge need is really because communication is fundamental to human nature. No matter it's Zoom where you can see each other, or for example, talk to each other, or whether it's email, right? So compared with mail, right? It's impossible to go back to the age of just do everything through mail. Okay, just to do everything through USPS, right? It's gonna take forever to just send a message. Okay, and so again, those key concepts in the networking here are still older concepts. Okay, we will stick to these concepts basically, right? So we are repeating things. Again, one important purpose of this course is to build a mindset for you guys so that you are familiar with those concepts, right? So because the technology can change forever, but there's something fundamental down there that it never changes. Okay, so these concepts are always there. So one is called speed or bandwidth, right? So there's a why we call speed and bandwidth kind of similar thing, right? So this is actually, both of them are what we call throughput. Let me put the word here, okay? Why I'm using this code. Throughput, okay, so what it means is this, right? So you think about it, when you send a message, it's actually is electric signal or light signal, right? If you use fiber, okay? That is sent from one end to the other, okay? And we know that this is a light speed, okay? Light speed is just saying that you cannot observe speed in some sense, right? And maybe because of the medium, it's maybe 2/3 of the light speed, but it's still very fast, okay? So let's say you send some message from East Coast to West Coast, there's some delay, okay? So we are talking about the latency right now, okay? So I will get back to the throughput, the bandwidth and speed later, okay? And speed actually also you can consider latency, but we really want to differentiate these two concepts. These are the two concepts we want to differentiate, okay? speed is what we call throughput, right? So because latency, when you think about light speed, it's really not a bottleneck. Usually it's really small percentage of your latency. Latency means how long when you send a message till this guy receives the message, right? So like if my network is very poor, maybe you will have 2 seconds of delay, right? So that's the latency, okay? Right. And when I talk to you, there's 2-second delay. You talk to me, 2-second delay. That's crazy, right? So I need to wait for 2 seconds to hear what you say, and you think I'm saying earlier, etc. I think all of you may have this experience, especially if you watch news. There's some delaying signals. You can see there's some emergency moment, right? So there's some latency requirement, okay, and the bandwidth requirement for certain service quality. That's for online gaming. Your latency is long, then that's crazy, right? If you hit some other player and that thing happen after 2 seconds, it will not. Work out, okay, right? So, and so this is called propagation delay from one side to the other. Really, maybe 10 nanoseconds, etc. You cannot feel it, okay? The true delay, the true latency, you can call latency and delay the same, okay? Comes from the router, okay? Because when you send a package, right, it needs to store it and then see which next router should go and forward. This is the true delay, okay? And we will discuss this later, okay? This is router. The propagation of the signal is really the propagation delay is nothing, okay? So the transmission, right, the transfer between routers, okay, because it stores and then forward, okay? That's the true delay at each router, okay? So you want to have less hops between two, right? You find the shortest path. This is routing path, okay? That's where the network layer is doing, okay? So it's routing, okay? So these concepts are all connected. And so this is latency, right? So we talked about, okay? There's also concept of bandwidth or speed, right? So what is speed? So one thing is that, let's say you are connected to Ethernet or you are connected to a wireless, router, right? And your device, how fast your device can put your bytes or your bits onto the wire, right? So how many, so usually we use how many BPS, okay, bits per second, okay? Right. So this is the unit we do, okay? If your wire cannot support very fast speed, let's say for your router, or for example, your Ethernet switch, let's consider switch, okay? And then you cannot send faster than this restriction, right? And so this is one restriction from the bandwidth, right? So there's 1 Mbps, right? Megabits per second. Note that when we call Mbps, this is bits. Okay, if you think about how many bytes, it's really 125 KB, right? So no, 1/8 of MB. Okay, right? So yeah, 125 KB, because it's bits and 8 bits is 1 byte. Okay, so when we talk about everything on the wire, we are counting using bits, right? But when we are in computer, we are doing bytes because CPU are operating on words, right? Like registers, AX, BX, CX, DX. When you do addition, you don't just do bit addition, right? You do a byte addition, okay? So in the computer, it's words, okay? It's byte, okay? But when it's putting on the wire and those connecting medium, okay? It's become bits. So this is just the practice of people, use these units, right? So we will see whether we will have some calculation problems about these, but we will get you prepared if we have exam question related to this. Do some calculation of the delay or throughput. Okay, no worry on that. And most likely we will try to avoid complicated mathematics, just to make sure you understand the concept, right? So that really means how much volume you can send from one side to the other, right? You maybe 1 Gbps, right? So which is a common Ethernet, bandwidth these days, which means 128 megabytes per second. Okay, so this is very important. For example, when you watch a YouTube video, right? So if you want a high quality, like a very clear quality of the video, right? So because there's different grade for you to choose, right? And then you really need the throughput, or we say the bandwidth to be high, okay? Right, bandwidth is BPS, okay? You don't care about latency because it's a video, right? If you are not interacting with the other party, 3 seconds delay is fine, okay? Because I'm watching the video, right? So I think you can manage that, right? So there are 2 different concepts, okay? So bandwidth and so always say throughput, right? We usually call it bandwidth and latency, okay, in networking. Bandwidth means how much volume you can send every second, okay, right? And latency means if you send from one side to the other, how long it will take. It can be really fast, but it cannot send too much content, right? Like if you are you're calling each other, right? So that data is really smaller than the video, okay? But in the video, you can have maybe 5 seconds delay, right? So, but that's fine, actually, if it's just a video, right? It's one-ended pushing, right? So if it's interaction, then latency and throughput both are, okay? Any questions? Right, so there's also encoding, right? So encoding is very important. Just think about the protocols, right? They are all kind of one way of encoding things, right? In different layers, okay? How the sender side will put those content in meaningful bits, right? And the receiver side, when it sees these bits, how it can decode them into the relevant content and put into your computer, like the memory, etc. Okay. And I think multiplexing is a particular concept. Let's briefly introduce what it is. Okay, and then we will look at the switching and routing. What are the differences? Okay, multiplexing, for example, we are talking about the application layer, right? And then we have the transport layer, right? Let's call it TCP. Okay. And we all, let me try to use text, okay? Let's say this is TCP. You don't care about where it's routed because it's a transport layer, okay? So you will put some content here and you want to reach here, right? The problem is that you may have different applications, right? This is email, right? And so this is another game, right? So you want to communicate, they do not interfere with each other, right? How do you do that? So one thing is that each machine has its own IP address, right? So this is, for example, IP address 1, okay. IP1, this is IP2. But how do you guarantee, for example, so this game will not send the content to the email, right? So that's through so-called multiplexing, okay? So think about it. So what happens actually, everyone will use port, okay? So when you set up something, right, you always ask you to give a port. And they should have different port, okay? And the destination should also have a unique different port, okay? Right, and then your email will, your game will only go to that game with that specific port for your for your application, right? Email will go to the email port, okay? There are some well-known port for, let's say, email, etc. Okay, and you can also specify your port for your own app, right? So they don't interfere with each other. Yeah, I think there's a. So can you hear me clearly now? Okay, thank you. Yeah, I think there's a feedback that the audio is not clear. Okay, just let me know if that's the case. All right, thank you. Yeah, so there's two possibilities. One is my end has a limitation, right? So another possibility is that the network on your side is not good, right? So we need to figure out what's happening. Okay, yeah. So that's why I need to ask everyone. All right, so this is called multiplexing because everyone, finally what happens is on the same wire, right? It's just a bit stream. Okay, this bit stream may belong to this application, and while this bits belong to that application, right? This is called multiplexing, right? Many to one into a bit stream. Okay, but on the destination, you have some encoding scheme. You know that hey, these go to this application, and this go to this application. This is called demultiplexing. Okay, demultiplexing. We will see more on this later. Okay, when we talk about the transport layer, right? Okay, I see. I will figure it out. Okay, so yeah, let me be closer to the Mac. So whether let's see whether the quality will be a bit better. Okay. And now, if you look at the cable, so there's a packet and circuit switching, right? We talked about this later, earlier, right? So there's also a concept of cable management, right? So cable management itself can be a discipline, actually, especially on the backbone and in the data centers, right? So you have all these links, right? You want to connect machines in the data center and between routers, etc. Okay. for that purpose, you have a lot of whiles. Okay, so if you look at, let me see whether, let me get a browser there. Okay, let's say table management. Okay, so you can see there's like a devices to organize these tables. Okay, so that's actually itself is some techniques that you need a certificate to do that, right? So and to help deploy those things. Okay, so that otherwise it will be a nightmare. Okay, in the data center, right? We need to have some way to manage these things and make them organized and easy to maintain and replace, etc. Okay, so yeah, so let me. I think we will not reach too much on the next slide, but we'll try. Okay, so and finally switching. Switching. Let's look at the concept. Okay, so there's three devices, right? So phone we need a switch, right, from one end to the other end. Okay, let me see. Yeah. So here actually in computer networks, we also have three devices. Okay, it's low layers. Okay, so we have hub. Okay, so hub and the switch, right? And then we have router. Okay, I think it's good to describe these differences right now because then you understand what is which, right? Better. Okay, so hub is something like this. Right? So if you have three machines ABC here, okay, and the message sent by a hub by computer A will also come to other computers. What does that mean? Okay, so this is what's happening. Okay, so for example, A wants to send a message to B. Okay, but in the meanwhile, it's like these wells are one piece. Okay, C will also see that. Okay, but like we said, there's a protocol, right? So A will say, hey, I'm sending to B. C will ignore it. Okay, but if you look at the bandwidth, that particular time slot, C is wasted, right? So C just like see A's message to B. Okay, it just ignore it, right? But it's not using the network. Okay, so switch is much better. Okay, so you know, as we said, switch is like in the phone, it's like, hey, this guy is connected to this guy by connecting this point, and this guy is connected to this guy by connecting this point. They don't interfere with each other, right? So this, of course, is more expensive because you need some switch, like a logic there, right? So in the hardware. Okay, so this allows A to send the stuff to D, and in the meanwhile, B can send stuff to C. Okay, right? So you don't see each other only end to end. Okay, so this is switch, right? And finally, there's a concept of router, right? So router, really, we go to the backbone network usually, or if you may have some like in the same like a company or in the same institute, right? So because you have so many employees, right? So many servers, you may also have internal router, okay? And you have a gateway router to the outside, okay? And so if you look at router really is care about routes, right? If you have here in company A in Birmingham and to New York in another company, right? Which route you choose to minimize the latency? We talk about latency, right? The shortest path to reach there. Okay, you don't want to stand it too slow, but the latency can change, right? Because you know a lot of people also are using maybe this route. Then you want to reroute to other routes, etc. Okay, so there are a lot of stuff that router is doing that we will cover later. Okay. And yeah, so that's the difference. And again, as we talked about the OSI model, right? Hub is really in the physical layer, right? So so let's say what we talked about, the hub is just like making these three wires the same wire, okay? They do not do any isolation, okay? And if you look at switch, okay, switch is really in the linked layer, right? So it's one hop to the other neighbor link, okay? Right. So you don't have multi-hops. If you need a multi-hop, then you need to choose a route. Okay, then it's just a router in the network layer. Okay, it's IP. Okay, above that we have the transport layer, and then we have the application. Okay, yeah. Here we are trying to repeat these things to help you memorize. Application layer, transport layer, network layer, top down. Okay, and then link layer and the physical. Okay, and there's some other layer in the OSI model, but that's not that important. You will see that. Okay. Yeah, I hope these are clear. Yeah, so yeah, so these are some important concepts, right? So I hope at least you get an impression of these. You don't need to, because we will cover them later. Okay, so you don't have to understand everything from them. Okay, and so the internet has changed the world a lot, right? So you cannot live without it these days, right? Communication is kind of free, right? And as long as you are connect to the service provider or you connect to like like if you are in UAB, then UAB connect to the service provider. Okay, so then basically you can send whatever you want. Okay. Yeah. So I see a student asked a question. It's not clear for you. You mean the voice or the content? What? Oh, the voice, right? So can other student follow, or I should be closer to the mic or speak louder? Okay. Yeah. So okay. Thank you. Yeah. So I think I will share the video on YouTube if you. Yeah, it's possible. So there are two possibilities. One is, for example, when I speak, right? So when I speak, so there are two possibilities. We need to figure out what's happening. Right? One possibility is, this is backbone, right? And this is you, and this is other student. One possibility is my voice is really bad to you because on your receiver side, there's a restriction, right? But on the other side, it's good, right? Because it's a different routes, okay? Another possibility is this part is really wrong. And that's where then everyone will experience something, okay? We will see, but we will share video, okay? Yeah, maybe on my side there's some some problem. Okay, so the backbone network, because these days everyone is using the internet, right? I will share the
video. Can I ask a question?
Everyone can hear. Okay. Yeah. Well, Daniel.
Yes.
Yeah.
So I was going to ask, and this might be a dumb question.
Okay.
But so is this like, are you just giving us background on what we're going to be tested on, or is this what we're going to be tested on?
So here we are giving you a very introductory background. Okay, so later we have the individual chapters on the details that you will be tested on. Is this clear?
Okay, yeah, just making sure, because I was just trying to figure out, like, so this is just kind of like a background of
this is the background, the concept overview kind of thing, right? So you yeah, so you try your best to understand, because we will repeat these things in more detail in later chapters. Would that be okay?
Okay, so it'll just be like more emphasized in later chapters as we go on.
Yeah, this is kind of like this first week, right? Because 1 week we have 3 classes. This is the third class, right? So in the first class, yeah, okay. Yeah.
Okay, cool.
Yeah, you don't
I
worry
about know if I can put in my Quizlet or not.
Yeah, you don't worry about too much for now. Okay, it's for be relaxed for so far. Okay, and then in later chapters, each details you do need to understand. Okay.
Okay, awesome. Thanks.
You're welcome. Yeah, so basically now it's kind of free and also freedom, right? So freedom, that's a good thing, but you also cannot control how others like can abuse, send an offensive message, right? So you cannot control others, right? So sometimes you will be harassed, okay? And so the world is definitely shrunk, right? So you can talk to each other without a geographic limitation, okay? And especially you think about the way it's changed, just to look at how we are teaching, right? So it's already changed a lot. And yeah, again, so one thing that it helps the productivity so much, right? So you don't have to drive to the classroom and then drive back, and you can just connect maybe 3 minutes before the class, right? So it improves the overall productivity. But on the other hand, because you may watch a lot of videos and chat with friends a lot, and so sometimes it's also you will spend more leisure time than before, right? So there's this. You can see if you want to do more improving of yourself, right? Maybe this wasted quite some time also, right? So it's really your choice. Okay, so then the reason why internet is growing so quickly is because of the design of the backbone internet, right? So it's a simple API, the OSI models. We will see more detail in the next class. Okay, it's an open network where you don't have control of others, but when you connect, you can connect to everyone else. Okay. I think that's all for today. And we will take attendance. Okay, so we will take maybe a quick attendance, which means we just sample 5 people, okay? And I will mark everyone present, and we will sample five names.
I got to class a little late. I thought our class was at 2:30. Will I still get on for attendance?
No,
I got on about like 2:45.
Yeah. No, it's a 15-minute class, right? It's 3:20, right? If I'm wrong, just correct me.
Okay.
Yeah, it's 50 because we have 3 times per week, right? Altogether, 2 hour and 2.5 hours. Okay. Yeah, let's really make it quick. I don't want to, really delay all of you guys. Okay, let's. So this student asked for leave. Okay. Quentin Coley, are you here? If yes, you can unmute yourself. Let me know. Okay, so I see your chat. Okay, and Jialin King, are you here? Jialin King.
I'm here.
Okay, let's sample another. Sarah Newton.
Hey.
Sarah Newton.
Some flats, 5 flats.
I'm here.
Okay, let's go to another list. Okay, so. Guvia Pabla, are you here?
Present, sir.
Okay, am I pronouncing your name correctly? Guvia?
Yes, it's Gurveer. Gurveer.
Okay. And the last one.
Gurveer.
That's simple. Okay, thank you. Curti.
Hey, 5 flats.
Curti.
Yes, present.
Okay.
Present, professor.
Okay, so that's all for today. Yeah, thank you, and see you.
Thank you.
Hit this goal, try to get 100,000 this year. And stop.
I will send this video
I don't
on
know.
YouTube so that everyone can get it. Let me mute. Okay, so if you have any question, feel free to ask now. If I don't hear about the question in 1 minute, I will. Thank you. And for the first 3 classes, just be relaxed. Okay, it's just to build a mindset so that it will be easier for you.
I have a question, Dan.
Oops, sorry.
Okay, what's your question?
So I was kind of listening. I think I missed when you were doing the roll call. So you're for the roll call, you just mark everybody here. I mean, because I don't understand that portion. And then when you were discussing the information that we just went over, none of that you said would be tested per se, or yes?
No, they will be tested, but they will be covered in more detail in later chapters. So if you you just get a concept now, and the vague concept is fine. And in later chapters, you do need to understand them. But this is an overview.
Right.
Yeah. So tested, but we will cover them again in more detail. That's what I'm saying.
Right. Okay.
Yeah. And we will not cover like things like in which year there's a TCP/IP flag day, those kind of questions. Okay.
So right. So we don't have to per se know the years of that information.
Yeah, this is not a history course. It's as long as you know the concept, right? You can apply them in real life. That's good. Okay.
Right. Okay.
We will not test you unreasonable questions. Right. Yeah.
Okay. And then what about the attendance thing? Because I see like in your under the assignments, if you click on assignment, it has that attendance thing there. But are we able to see that, or just you mark us here or not?
I think I mark you guys here, but you cannot see other people's attendance because of the privacy reasons.
Right.
By Canvas. Okay, it's not set by me. Okay.
Okay.
Usually you cannot see other students' performance.
Right.
Yeah.
Okay.
You can see your attendance if there's anything wrong.
Does it show my name on there? Oh no, I can't see my name on there.
Let me see. I think it should be there. Let me see. So you're undergraduate student or graduate student? Yeah. So you're here, right? I think that's your name. Okay.
No, I'm Daniel. Daniel, Daniel.
Yeah, is this you? Can you see my screen?
No. My last name starts with an O.
Yes, it's yeah. Are we seeing the same screen? I mean, what do you see on the screen right now?
My last name starts with an O.
Yes, let me stop here and share the screen again. So maybe I'm showing a wrong screen. You see the screen now? Yeah, I think this is your name, right? If, anyway, so I think your name is right here, so don't worry, okay?
Yeah, that's me.
Yeah. So,
Okay, cool.
Yeah,
I was just making sure that.
yeah. What did you see earlier? I think it should be the same page, right? So you didn't see it earlier?
I saw Patel. It was starts with a P. The last name started with a P.
Oh, I think maybe there's some
believe.
internet delay in the video, maybe. Okay.
Oh, okay.
Yeah, that's why. Yeah, maybe voice is
cool.
here. Okay. Any other questions? I see one question, by the way. So what textbook chapters? So for now, the textbook chapter is the same as we shared earlier. We have 2 reference chapters, okay? As long as you understand everything in the video, that will be fine. But if you want to do additional reading to help you deepen your understanding, just check my previous announcement, okay? And for the next slide, I will have another chapter accompanied, and I will let you guys know, right? And any other questions? By the way, we will have the lab, okay, from this week, this Friday.
Mr. Yan, I'm having a hard time
Yeah.
understanding you. It's not necessarily like,
Mhm.
I don't know, it's just really staticky when you talk, and it's nothing wrong with my router or my Wi-Fi or anything like that.
Okay.
It's not nothing wrong with my computer either. I have headphones on and the volume's all the way up, and I'm still having a hard time understanding you since last Friday.
I see. Let me test it out. Okay. I will do more testing before next class. I will look at the video and try to make it work. Okay.
Okay.
Yeah.
Thank
So this
you.
time we do have the video. You can watch the video, see whether it will be clearer. And then next time I will do more testing, make sure the Mac here is working well. Right.
Okay.
Yeah. Okay. Thank you. Thank you for the feedback.
You're welcome.
Yeah, maybe I have a fan in the background, which is very noisy. Let me see how to make it better. Okay, yeah, we sampled 5 people today, and all of them are here. So if you are grabbing water, and that's fine. Okay, so we don't see anyone missing today. Okay, yeah, you are tick. Yeah, have a good day. I think there are no more questions. Right. Yeah, I see another question. So there's a time conflict every Wednesday. Yeah, you'd better email me, because the way we work on this is that I will take your name, right? So if you ask for leave, I will take your leave. Then I have a record, and I will see I should not cross you in some way, right? And yeah, before the class every Wednesday. Okay, would that be okay? Yeah. Okay. Thank you. Yeah, just to remind me, so I will keep it on the list, so I know that you asked for me. Okay. Have a good day then, everyone. And if you have further questions, just send me email. I will try to improve the quality of the audio, and I will upload the video for today. Okay. Thank you. Bye.